Hello and good morning everyone. Today inshallah it's going to be our last lecture for this course, Calculus 1 in SPE. We will talk today about the antiderivative, the last part, but I'm going to focus today with the improper integral, as we already covered most of the stuff in the previous lectures, alhamdulillah. So we will start our lecture inshallah by the definition of what's an improper integral, how to deal with it, and what's the different cases that we will see. Of course, as you know, all of our course notes, references, you will find them on Moodle, and all the recorded lectures, you will find them on the YouTube channel. And also I've shared this PDF with you earlier this week. Inshallah, beginning from the next week, if you got any questions or anything, just stop by our office and I will be with you, will be very happy to go through it with you. Also, I want you to go through the through Moodle. You will find most of the previous exams for the final exam. I want you to check them all and try to solve, and the bottom line, try to solve using your hand. Try to solve using your hand. This is really a very important advice. Don't just watch the videos, watch the problems solved in front of you. Try to resolve them. This is major. I usually do this before each lecture when I'm going to start reviewing something or doing something with you. I usually like to grab just a pen and paper and start to solve these problems more than once. Then you will find everything is really very easy. As I told you, our agenda today, we will start with the definition of the improper integrals. We have two types of them. We will go through them. Then I've tried to put as much problems as it will take just to grab most of the ideas about this topic. So the first case that you may face is the integral function is not bounded in AB. There is a singularity point, or a point at which we usually say that the integration or the integrand explodes. Okay? So in this case, when the integrand explodes within the interval or at any of the endpoints of the integration interval. So I want you to take a good look for the problems that we will go through it. Each one of them convey a message and tell you how to deal with it. So if you look to the first problem, which is a definite integration from 0 to 1 to really a very simple problem, which is 2 over the root of x. So if I try to solve this problem, the first thing to do is to check within the integration interval and the limits of integration. If you remark, the first remark that will hit you is that this function is undefined at 0, because at the lower limit, if you try to substitute by 0, you will end up having 2 over 0, which is undefined quantity. So the first step will be analyze your problem and identify the singularity. The singularity will happen at the lower limit when x is equal to 0. So how to go around this issue? I will replace this value, which will cause a problem to all of us, by some constant, like theta, like t, like whatever. So the second step, I will use a limit. I will rewrite this integration. As I told you, I usually like to use my limit. So instead of integrating from 0 to 1 over 2 over root of an x dx, I will replace it to be the integration from t to 1 for 2 over the root of x with respect to dx. This way, I will be able to do my integration and delay the problem that will arise. And in order to make things really very easy for me, and I will take limit t, which will go to 0. That's the key point. Use the limit to replace by theta. So I will replace my problem by a constant, either t, either theta, as you can see. So I will rewrite my integration, and instead of dealing with from 0 to 1, 2 times x to the power of negative half dx, which is 2 over root of x, of course, I will let it to be limit epsilon tends to 0. I'm writing 0 plus because 0 is the lower limit of my interval. So the interval will be between 0 and, between 0 and 1. This is why we write 0 positive, but you can just write 0. So it's a limit of epsilon tends to 0 from epsilon to 1 for 2x to the power of negative half. The second step, I will integrate. Normally, I will neglect this problem out of my head. So integrating, it's an x to the power of negative half. So all I have to do is to increase power 1 on the power and then by the new power. So the integration will be 4x to the power of half, as you can see. Then I will replace by the two values which are 1 and epsilon. So it will come to this. 4, open your bracket, substitute by 1, which is going to equal to 1, minus substitute by the lower limit, which is going to be the root of epsilon. Take the limit is epsilon tends to 0. So once you do this, the limit is going to be equal to 4. If the limit exists, if it is a defined number, then your integration is convergent to a certain number, as you can see. It's really very simple. So all I have to do is to, step number 1, analyze your problem, identify the singularity point, use the limit instead of the part that's causing the problem, see if it converges or diverges after taking the limit. So I will write my integration. I will complete the integration x to the power of half over half, exactly as we said. And then you have, of course, you know, a denominator. The denominator is a denominator. So it will come to 4 root of x. Then I will substitute and take the limit by 1 and epsilon. It will be 4, and since it is already exists, your integral is convergent. As you can see, the topic is really very simple. So it is all about identifying what's the problem, how to manage this problem carefully, and then integrate, take the limit, you are all set. This is really a very nice problem to show you all the steps exactly and how it is going to be. Okay, let's go to the second problem. The second problem, I want to integrate from 0 to 8. Okay, 1 over the cubic root of 8 minus 5 to the power of 5 with respect to the x, as you can see. So once more, I need to identify the problem. So a good identification of this problem will lead to the upper limit, not the lower limit, the upper limit. If you substitute by 0, it's going to be x minus 0 to the power of 5, so there is no problem. But if you substitute with 8, it's going to be 8 minus 8, which is going to make the denominator equal to 0, and now that's a problem. So first of all, I will need to identify my problem, analyze the problem, and identify the singularity part. The second step after doing this, which is going to happen at 8, I will replace my 8 by a constant, epsilon, t, whatever. Then drive this t or constant that it will tend to 8, which is going to give the problem. So now I'm using the limit, so simply I can do it this way. I can write, I will take the limit of epsilon tends to 8, the problem, which is going to be an integration from 0 to epsilon for x minus 8 to the power of negative of a 5 over 3 with respect to the x. Integrate, then substitute by the limits, by the integration limits, then start working with your limit. So once more, if I do this, this is what's going to happen. So that's my problem. If I want to integrate, of course, I will add 1 and then divide on the new power. So if you add 1 on this power, it's going to be x minus 8 to the power of negative 2 over 3, I think, divided by negative 2 over 3, which means you will multiply by 2 by negative 3 over 2, because you are, of course, when you are dividing on 2 over 3, it will be replaced as you can see. Then I will start substituting by the values. This is 0 and that's epsilon, and that's the limit of epsilon tends to 8, and then trying to work my way through it. Of course, if you try to substitute with epsilon after integration, which is going to be the 8 issue, it's going to equal to negative 3 over 2. That's the limit of epsilon tends to 8, and your integration will be epsilon minus 8 to the power of negative 2 over 3. Remark the negative sign. So if you do a substitution, you will end up having the negative infinity, which means your integrand, your integration is divergent. As I told you, it's really very simple. Just change the integration limits, then substitute. So once more, use the limit, then see if it is convergent or divergent, as I told you. So once more, it's at x minus 8 to the power of negative 5 over 3. Add 1, so it's going to be negative 2 over 3 divided by negative 2 over 3. The next step, okay, is start to use the limit, which is going to lead you to negative 3 over 2x minus 8 to the power of negative 2 over 3 from 0 to t of epsilon, and the epsilon tends to 8. Once it hits 8, it will be undefined. So since the limit doesn't exist, it's an undefined value, then your integration is divergent. That's the first part of the improper integral, as you can see, that we will need to deal with. I've added a bunch of problems just to make you feel comfortable dealing with this issue. And this is what you will see in the coming slides. I've added like 10 problems or 10 exercises. All of them are solved. I will go through them quickly with you. So this one is 1 over root of x. The x still, yes, you are correct, still the problem when x is equal to 0, it will be a division over 0. So quickly, what can we do? All we have to do is to just rewrite this problem to be x to the power of negative 1 over 2. Then I will integrate, which means I will add 1 on the power and divide on the new power. So after integration, it's going to be 2 over root of x. I will use the limit and I will start substituting. So I'm using my limit. It's a limit epsilon tends to 0. The integrand, or the integration, it's 2 root of x. I will start substituting by 1 first, minus, I will substitute by theta, as you can see. Then theta will tend to 0, which means this part will be cancelled or eliminated. So the value of the integration only exists, which is 2, which means your integration is convergent, as you can see. Another problem with the same scenario, if I have x to the power of negative 2 over 3, the x from 0 to 1, similar steps, exactly the same. The problem will happen when x is equal to 0. So all I have to do is to integrate first, then write instead of the integration limit that gives you the problem, the limit value, then apply the limit and finish your problem. So once more, it's going to be x to the power of 1 over third over 1 over third. Then I will substitute from 1 to t, as you can see, or from epsilon to 1, or from t to 1. Then I will replace every x by 1 first. Then I will replace x by epsilon. Take the limit tends to 0. This part is going to be cancelled. So it is approaching, as t approaching 0. Then your integration will approach 3, which means it's a convergent integration, as you can see. Another problem, which is 1 over x to the power of 2. So integrating is going to be x to the power of negative x to the power of negative 1. Also, the problem will arise for us. Let's see if we use the substitution of the limit which tends to infinity. So it's going to be exactly the same. So it's going to be negative x to the power of negative 1 from 1 to b, and the b tends to infinity. If you try to substitute with b equal to infinity, it's going to equal to 0. If you try to substitute with 1, so it's going to be negative of a negative 1, which means it's a positive 1, also a convergent integration, as you can see. This problem is 1 over x, which will cause you a problem when it hits 0, exactly like the one that we had before. The integration will be ln of x. So integrating 1 of x, it will be ln of x. Once more, after integrating, I will add the limit, so it's going to be a limit of t tends to 0 for a ln of x. Then I will substitute by 1 and 0. Once you substitute by 1, you will have ln 1, which equal to 0, minus a ln of a 0, which tends to negative infinity times negative. It's going to equal to infinity, which is a divergent integration. And as I told you, the steps are really very simple. Identify the problem, use the limit, then substitute, and then the result will be in front of you. Another problem, this is problem number 5, and for the same problem, which is 1 over x dx, but I will change it, the integration limits to be 1 up to infinity. So from 0 to 1, and then from 1 up to infinity. Also, this is going to be a divergent integration, because once you integrate 1 over x, it's going to be ln of x. Once you use b tends to infinity, it's going to be ln infinity, which tends to infinity, and that's a divergent integration, or as t approaches infinity, the integration will tend to infinity, and so it's a divergent integration, as you can see. The topic is very, very simple and also handle. If you look to ln of x dx, you can take all the ideas of the integration, either integration by parts, using rational roots, whatever. But if you look to this one, it's a ln x dx from 0 to 1. Yes, you are correct. I will need integration by parts in order to integrate this problem. I will consider ln of x times 1, as you know. Then integrating is gonna 1, it's gonna be x times ln of x minus the integration, the integrated part, which is x, the untouched part, which is ln x, the differential is going to be 1 over x. So now I'm dealing with x, ln x minus 1, integrate 1, which is going to be an x, then use b substitution. I have a problem in all times with 0, so I will replace it from t to 1. I will take the limit when t tends to 0. Once more, I will try to substitute. So if you substitute by 1, it's going to be 1 times ln 1, which is 0, minus 1. That's for the upper limit, minus. I will use my t. So it's going to be a limit of a t tends to 0 for t times ln t, as you can see. Minus a limit t tends to 0 for t, which is going to equal to 0. I will try to handle this part. This is going to be a limit of t tends to 0, as you can see. And then I will try to substitute, which is going to be, if you remember, we handled this before. So it's going to be from Cauchy. So it's ln t over 1 over t. Both of them are undefined. So I will differentiate the denominator, which is going to come up to 1 over t, as you can see. Differentiate the denominator, which is going to be negative 1 over t squared, rearrange. So it's going to be negative of a t, as I say. Limit t tends to 0, so this part is going to cancel. It's going to be cancelled, and the result will be negative 1 for this integration. Check the signs again for this problem, and we will resolve it together, as you will see. This is really a very good problem. As you can see, we can use any of the integration cases. So I will integrate, as I told you, integration by parts. I will have x ln x minus x. I will use epsilon tends to 0 instead of t. So this is going to be the case. I'm trying to substitute, simplifying, using the limit, so I will end up having -1, exactly like the previous problem. So it's a convergent integration, convergent improper integral force. 1 over the square root of 4 minus x, if you integrate, it's going to be 4 minus x to the power of half times 2, then you will substitute by the limit. Once more, I have a problem with 4, so I will use the limit for this integration. After integrating, I will take the limit when t tends to 4 and substituting, so the value will be 4 as you can see. This is the last problem, I believe, in this batch, which is the integration from 0 to 2, 1 over 2 minus x to the power of 2. In this problem, I made the substitution to solve the problem of integration, although I can solve it, of course, without substitution, but you know, it's a child just to show it to you. So I've assumed that 2 minus x is equal to u. Integrating first, I will have negative u to the power of -1. I've replaced u once more by 2 minus x, so I'm dealing with -1 over 2 minus x from 0 to t. If you substitute by 2, or as t tends to 2, then your value is going to be undefined, and in this case, it's going to be a divergent integration, or your integration is divergent. Those are the problems for the first part, or the first case. If I have something like this, which is e to the power of -x from 0 up to infinity, and here the integration limits are unbounded or tending to infinity, as you can see. And if it happened, in this case, something like this, all I have to do is just integrate, but be careful for the exponential function. Because you know, e to the power of -x, after integration, it's going to be a negative of an e to the power of -x, which is simply -1 over e to the power of x. So if you try to substitute from 0 to infinity, this is not going to be a problem, actually. As x tends to infinity, the value will tend to 0. So if we make this substitution, it's going to be a -1 divided by infinity minus, which is going to be a positive, 1 over e to the power of 0, and so the first part will be 0, the second part will be a positive 1, as you can see. So it is a convergent integration. So once more, it's really very simple. I've replaced the problem when x tends to b and the b tends to infinity, as you can see. Integrating will give you the same result, as you can see. It's a convergent integration. Problem number 10, it's an x to the power of -3 over 2 integrating. It's going to be -x to the power of half. And from the experience, -x to the power of half, if you try to substitute, it will tend to infinity. This is why it is divergent. X times e to the power of -x. Once more, I will need your skills in integration by parts. So for this problem, I would say that I will equal to a negative of an e to the power of -x times x minus integration. The integrated part will go down. So negative times negative will be positive. This is going to be e to the power of -x. Differentiating x, which is going to be a 1. Then finalizing your problem, which is going to be -x to the power of -x. Integrating minus e to the power of -x. Then plus the constant of integration. Of course, we are not going to put it. Then I will have my limits from 0 to b, and that's the limit of b tends to infinity, and start resubstituting once more. We should remember that e to the power of -infinity is equal to 0. So once more, as I told you, we will do the integration by parts. That's the result that we will have, exactly like what we did. Then we will start substituting by the limit. You will end up having 1, and once more the problem is convergent, and you have no problem whatsoever with this integration. It's a convergent integration. The second case in particular, it will deal with the limits if they are undefined. So that's the second case of the improper integrals, where the unbounded interval of integration, like the problems which we saw previously, there will be no problem in this one. This is going to be a convergent, and also in the last one it will be a convergent from a log of an I from the experience of our like the problems that we solve. But this guy needs an attention. Question number 3. So once more, e to the power of negative x, I will start to integrate, as you can see. So it's gonna be e to the power of negative x. Once x tends to infinity after integration, it will be the same. So it's gonna come up to 0, it will converge to 0, and this is why the first part of integration will be cancelled, leaving us with the second limit after substitution, which is going to equal to 1. So it is a convergent integration. If you want to solve it real quick, it is also possible. So I can write I is equal to the integration of e to the power of negative x dx. Integrating is going to be negative e to the power of negative x. Then I will try to substitute from 0 up to infinity. It's going to be negative of an e to the power of negative infinity. Minus and minus is going to be a positive e to the power of 0. The first part will contain no problems. It will be a 0 plus a 1, so the result is 1. So either using the limit issue or just trying to solve your problem, both of them are handleable with no problem whatsoever, as you can see. So once more, this is how to go through it. But for the problem of 6 over x, once you integrate this guy, it's going to be 6 over ln of x. Once you integrate, it's going to be 6 ln x. If x approaches infinity, this is going to be infinity. So it's going to be undefined, as you can see, and the integral is going to be divergent. The same problem may happen with this guy, because of course this is going to be a negative x times e to the power of negative 2x. That's an integration by parts problem. So integrating, it will leave you with this guy. Then I will try to substitute by the integration limits. I think this part will cause the problem. This is undefined part once x tends to infinity. This guy will remain tends to infinity. And so the problem is, as I told you, divergent, as you can see. From all of this, we come to the end of our course. I want you to remember that the antiderivative part is very, very simple. We did go through the antiderivative of basic functions, then how to integrate by partial fractions, then integration by parts, then integration by substitution, then the area and the difference between the different integration and the area, and then finally the improper integration, as you can see. I don't want to be too much on this last lecture, but I'm really very happy that we already finished our course, and we will start reviewing our lectures, inshallah, in the coming period. So please, if you have any questions, do not hesitate just to stop by. We'll be in our office most of the week, so if you need anything, just let me know. Thank you very much, and please, as I told you 100 times, try to solve as much as possible, and then try to review all the problems that the previous exams, on Moodle, you will have them all and also solve it. So I don't think you'll have any problems, but just please start, don't delay starting solving your exams. And most of the exams is going to be within by the end of this month. So you are talking about after Eid or something, maybe some of them will be before the Eid by the 25th. So you will have like 10 days or something. So please start work. Thank you very much. And as I told you, if you need anything, don't hesitate to stop by. Thank you. Bye-bye.